Well, I don't have a whole lot of time in the shop this morning, but wanted to try to do some test fitting, some mock-up, finish up, follow up on some other stuff. This is a strut out of a Datsun 710, 77 I believe. So basically what I'm trying to do is, and it's pretty much already been figured out, okay? I'm just doing some follow-up to verify that the CAD work I've done actually fits and matches, so it's part of the prototyping process. But I figured I'd kind of get you caught up to speed here since we didn't I didn't record any of this while I was doing it with Jesse and Adam. So anyway, 710 strut. This is the stock rotor, okay? This is the rotor we're going to use, okay? That's off Ultima. Really should probably clean some of this junk up here, but anyway, so you can see it's a good bit bigger, and it's also a nice vented one. Okay, height-wise, you know, they're off there a bit, but the fronts are actually real close to each other. So that's neither here nor there. So anyway, let's put that one up. Now that did bolt onto the backside. Now we did find another rotor. I don't have it here anymore. I took it back. It was brand new. I didn't want to use what it was. It was a smaller diameter than this one, designed to fit on the back. I don't remember exactly what car it came off of. Doesn't matter. Anyway, bolted on the back. The diameter was too small for the caliper to be able to get in here and clear. Okay, so this is the stock 710 caliper. Look at how tiny those pads are. Okay, this is the caliper that's going to be used. And I mean, you can see right there that we've got easily twice the pad area there. Okay, pad surface. So anyway, I machined the hub down. Really didn't have to take a great deal off, not even a 1/4 inch, and you can see there's still quite a bit of metal out there. Certainly when you compare it to the Roadster hub, which I don't have handy. Anyway, you know, this kind of stuff's at the owner's discretion on that, whether or not they want to do that. But anyway, that's been machined to fit on the backside here. Okay, so let's turn that over, put a couple lug nuts on it. And I kept the hub pretty accurate because it won't register hub centric on the front side, so it's actually pretty darn close to being perfectly hub centric on the back there. So let's flip that over. So that's sitting down on the bearing. I'm going to go ahead and put the nasty greasy ass parts back on here for a minute, or at least to do what I'm doing now. According to Morrison on Ratson, the 210 strut and the 710 strut are the same. Okay, so he's working on a modification for those guys who are more concerned with weight. So instead of using this big ass heavy vented rotor on the 210s and stuff like that, it'll actually use a smaller, thinner one like we did with the 1200s. And he'll have that option available fairly soon or whatever. So okay, so I'm going to try to do this so that it's not exactly convenient for me, but might make it a little easier for you to see from that angle. So this is one prototype we had. Now, basically, I cut out a quick one out of aluminum there once I figured out roughly where I wanted it. So let's see what we've got for bolts here to hold this stuff together. And these aren't anywhere close to being accurate. At least not in, at least not these. Okay. Alright, I got that one touched down there. Let's see if I can get the pads back in the bracket here without knocking all the other ones out. Oh. Now, these aren't new ones. I'm not too worried about that just yet. I think I'm going to have to prop this up a little bit. Yeah, this is supposed to be the fun part. Oh man, some days there's just no point waking up. So, you really got to kind of watch where you grab, because everywhere you want to squeeze right there in the middle, you can't do it. Yeah, it looks like my aluminum spacer is off just a little bit. So, the aluminum bracket. So, I did those. Put this down in there. Alright, that reaches. Okay, so what I'm double checking here, I can squeeze these together now. I couldn't, in CAD, these didn't line up where I wanted them. I don't know exactly why, because those holes should be perfectly concentric to the spindle, as well as these holes are concentric to the spindle. So, anyway, what I'm looking at here is along the back edge here, okay? You can see that I got a bigger gap here, if you can. Let's see if we can. Okay, so right over here, I got a bigger gap than here, which means that that hole needs to be closer in, which on the new CAD stuff that I came out, because on CAD I could draw it and make it perfectly concentric, okay? When you're just, you know, making these kind of things, you know, just winging it, trying to get them to fit and stuff like that, you're not extremely accurate. So the point is to then get it into the CAD and get it a little closer. So I would pull this hole up a little bit. That's okay there. And that one doesn't want to push down anymore, and that's fine. I could elongate that hole, but I'll check this piece against the CAD work and see how close it is and go from there. Oh, and then it's a G20 caliper that it's going to fit right on the back there, and I'll show you a little later clearances on the back side, and that stuff should all be fine. I'm still wrestling with the dimensions here. I cut out the CAD one, and it just still does not line up. So according to measurements and CAD and everything should fit, but when you look at it, it's just no way it will. So what I'm going to do here is I've got a centering punch. This is an old rotor. I don't have to worry about it. So what I've done is I've still got the pads clamped where I want them in alignment here. And so with them clamped on the rotor where I want, that holds this bracket, the mounting bracket, where I want it. So what I'm going to do here is I'm just going to put a little mark there. And of course, then I got to line all this crap up again after the fact. But, so we'll just take that off. And what I want to see here is put a circle around it here before we lose it. Okay. So yeah, I think you can see that. They look like they're pretty well the same distance. That's 56.73. Oh, we're a couple mil off here. That's 53.55. Okay, I'm on the wrong dot. Don't have to be too bright to beat me. Alright, let's check this dot. Oh, that's almost exactly, that's real close to 54. Yeah, it's 54 millimeters in. Okay, and that one's the same. Okay, so 54 millimeters. Let's just write that here for now. Okay, so it's real hard to measure to the center of the hub and the spindle. I do know how the diameter on this thing, on the rotor, so I can subtract the 54 from that and then go back into CAD and use that circle for the for those two holes. Yeah. Well, anyway, that's how I measured that. I may or may not use that. We'll see. But time to go hit the CAD again. Oh, add a little more to the 710 stuff here. Basically, this is off. This is a CAD print from the work I've been doing on the 710 bracket. Okay, so the cool thing with the CAD is that, you know, even if you don't have CNC and all that kind of stuff, these center marks, you know, if I measure them, I've got that set for 100 millimeters. Okay, so let's zero out the caliper here. And I may have shown this before, but I don't expect everybody to watch all the videos, so I'll repeat some stuff. So I'm at 99.995, and if I split the ink, oh yeah, if I split the ink line going up and down for a bit more accuracy, it's right at 100. So anyway, it's really accurate. Okay, so I can now take that accuracy and transfer it onto the aluminum and drill it manually. You know, I just have to punch it carefully and stuff like that, and I can easily get it within 10 thousandths. You know, 20 thousandths for sure. So what we'll do here is we'll just cut this out real quick. And the holes are my primary concern at this point, but since I'm really hoping to be close this time, this is the third time, I'll probably, I can't remember if I shot video of how I measured the caliper position this time or not, because that was kicking my butt. Well, bit of a bomb. And the corners just have to be close, no big deal. Okay, so we're going to get it pretty squared up on there. Ought to be close enough. And get kind of a down and dirty outline here with a Sharpie. Alright, so that won't do the trick, but this will. So I don't want to move it. What you want to do is you want to get it close to the perfect on that as you can. That was a little off. Oh, that was better. All right, so I've got my 4 holes there. So now I can drill those to whatever I want. Cut the outside. Might be easier for me to hang on to this and drill them first and then cut the outside, which is probably what I'm going to do. This is the one I had mocked up before, and it's the new one's pretty close. So what it is I'm trying to make a better one that doesn't have all the slop in the holes, so I can prove that this art is accurate and correct, and then I can submit it for a laser cut quote. It just so happens I still have the step drill in the drill press. And I brought the bolt with me. Oh, looks like I gotta go another one. That's nice. Of course, not very sharp, so it's not leaving a very nice edge there. Boy, you can feel the aluminum getting hot already. This bit's not very sharp either, so part of the challenge, but it's making a round enough hole for me to use. Yeah, that's what I was afraid of. The burr's keep. Well, let's just turn it this way. The burr was keeping it up where I couldn't get it flat. First couple of steps are definitely sharper. So, that ought to work. They're a little on the loose side, but I think close enough for what I'm trying to prove right now. All right, let's whip it out on the band side real quick. Now, this being a 1/2 inch blade, it's not going to let me do the curves very well, so I'll do those on the sander. And it's rather hot from the drilling. Got a pretty good radius going there. All right, close enough for now. Let's put it on the belt grinder. Start with changing the belt. So move up to heavier grit. This grinder doesn't have the nice cool shift lever arm to make it easy to change. And I'm looking for the arrow. Some of these belts are directional. Alright. If I can use these right, that's pretty close. Gets hot quick. Makes a nice soft radius there. I don't know if you can see that or not. The 8-inch makes a nice round soft radius there. This one's not quite as nice, but I'm not too worried about it for what I'm doing. But knife grinders use a big radius like that for a hollow grind, I guess, on the side of the blade. Not sure. Comes in handy for fabrication, though. I don't remember if I quite covered this yesterday or whatever when I was shooting. Okay, what I did here, let's I put this on, got it where I wanted the pads on the thing, and then I clamped it on. Okay, and if you can yeah, I think you can see them there. What I did was I took a centering punch and put it down through these holes, and it fit fairly snug. And so then I popped a hole. Then what I did was I measured from the outer edge to here, and that's 54 millimeters. And then I knew that this was 280, you know. So doing that, I divided the 280 in half, subtracted the 54. That told me exactly how far from the center of the spindle this mark was. And that's how I was able, in CAD, to go in and say, okay, I need these holes on the same center point as these holes. Okay, so this was 100 and I don't remember what the numbers were. Anyway, they're two different diameters that I was on, because these are concentric to the axle. I think I've mentioned that before, and I knew these needed to be concentric to the axle. So then what it is then, you know, I say, well, this one needs to be about here. I put that point in CAD, drew a line 100 millimeters to where it touched the other part of the circle, and put my other circle there. And that's roughly how I got it. So I'm not going to clamp this on because I want to see where it mounts on its own. So yeah, there's a little bit of play there. I should have drilled these a little bit more accurate. Alright. Missing a bolt. Where are you? Isn't that annoying? I'm sitting here yesterday Oh. I took it over to the drill press to check sizing. Alright, spacer. And these bolts just barely reach. But that's fine. If this proves the concept close enough, then I can submit it for a bid and go from there and decide what to do. You know, I might just make a couple of them by hand. Okay, I think you can see that. Let's. So I'm a hair high over here. Whoop. And that could be because I haven't rotated those around far enough. Easy enough fix. These are pretty much right where I want them. I don't think those are going to change a whole lot. But let's see how much of that is hole slop. Oh, that's almost down to where I want it. Seeing about a little twist changes it. Oh yeah, that's nice. That's nice. I could live with that. In CAD, I may go ahead and scoot those a little bit more that way. We'll see, but it's close enough I could submit it for a bid. And have a price, because I can make minor tweaks and changes to the dimensions from that point, as long as I'm not changing how many holes and the mass and the weight and all that kind of stuff too drastically. The price will come the same. So I imagine it will cost more for me to pay somebody else to make these spacers than it will to have, you know, for two of those than it will for the plate. But all depends on just how many of each I order. It's going to be such a low production run that I'll probably just get some DOM tubing, which I might already have, and I'll just do these myself. I think that's it for today. I'll go get back on the CAD and get that submitted for a price, because I got somebody else waiting for me to submit a bid on another bracket along with it. So that's it. Okay, one last little blip here, I think. This is the reason for the curve in here. Okay, I couldn't just go straight across, or I would be hitting the bottom of the caliper. I could probably go straight across here, but the casting's a little rough through there. So I need to put a plate on there flat and find out exactly what kind of room I've got. And may wire wheel it off, get some of the crud off and see, and I may go ahead and make this a little bigger around each of those to match these. These are set roughly at 28 millimeters, which is how big this pad is down here. Anyway, what I'm looking at, I put it back over the CAD template, and 3 of my holes came out really, really close. Okay, certainly close enough to use, even if this had been a steel final product. This one, on the other hand, shifted. I don't think it would have shifted like that in steel, drilling it with a regular drill bit instead of a unibit. But anyway, I was saying that this side was out a little too far, and then I needed to tweak it in a little bit. Well, had it drilled where it was supposed to, it would be tweaked in a little bit. So I'm really happy with the CAD. And I'm just going to go with that. That ought to be just perfect.